Okay, let's take a look at this problem and then we'll solve it with a TI83/84. We have a production manager with 3 methods of assembly. Has 36 workers, 12 of whom are randomly assigned to each of one of 3 methods. Okay, so we'll just bring in our calculator here, and the first thing we will want to do is select Stat and Edit, and we will enter the numbers from the problem. So you can see, for example, in list 1, I have 18, 19, 19, 25. Those are the numbers from here. And then so on for methods 2 and 3. If you need to, pause the video and put those in, and I will go ahead and just move on. So the next thing is to select Stat, and then Tests, then arrow up to ANOVA, select ANOVA, second L1, that means that your first set of numbers are in list 1, comma, second L2, comma, second L3. Of course, if you had more than 3 methods, you would just keep going in the same way. Close the parentheses and select Enter. And you can see there you have your f-test value of 8.15, a low p-value. It's less than 0.05 or less than 0.01. So using the common standards, that means that because the p-value is low, we would reject HO and conclude there is at least one difference between assembly methods in the population, not just the samples. For factor, which is the same thing as group or treatment, we have degrees of freedom of 2, sum of squares of about 801, and mean squares of a little more than 400. We can arrow down and see the same information for the error term, degrees of freedom, sum of squares, and mean squares. And as far as the ANOVA per se, that's it. I will go back also and review the calculation of sample statistics for each one of these methods, or I'll just do it for one and you can do the same thing for others. Stat, calc, one variable statistics, enter, and then just tell it which list you want to look at. I've got list 3 here, so we'll just arrow down, don't change the frequency thing, and hit calculate. And there you have the sample mean, the sample standard deviation, and so on. Now if you want the variance, you'll have to take that 8.13 and square it. I think that's what it was. And square it, and then you'll have your variance. That'll be it for this lecture.